Hello everyone. Today let's explore decision tree. In our real life, the tree is look like the left picture. It has root and also has many leaves. For our decision tree is just the opposite. It look like the right side of the picture. It looks more like the tree's root or the opposite of the tree. Now let's see the concept cart. CART means classification and regression tree. For CART, it can be divided into the classification trees and regression trees. For the gender and for judge if it's a dog or wolf, we use classification trees. We decide a man or a woman. We just put the person into one bucket, and those two buckets cannot be comparable. For the regression trees, the temperature, age, income, we can see those values are continuous, so they can use regression trees to solve it. Using some techniques, we can convert regression trees into classification trees. Like we use some range of the values to put into one bucket, then we can do the conversion. Now first let's see the decision tree used in our real life. We want to commute to another place. So first we look at the weather. The weather is sunny, is cloudy, is rainy. Then if it's raining, we will take the bus. If it's sunny, then we need another factor. We need to decide if we have enough time. If we have more than 30 minutes, we can walk there. If it's less than 30 minutes, we need to take the bus. Using these methods, we can finally define our decisions. We reach our decisions step by step, using several factors to decide it. Just like the decision tree used in our real life. Decision tree algorithm is also used the same strategy and it can be used on the data. We see the graph at the left side. We can see that the green dots and the red dots are mixed. We cannot use our previous algorithm to split them to distinguish one group from the other. Using the decision tree, we can draw some lines of split lines like the upper right of the picture. We use 4 split lines to split those data into several parts, and we can build decision tree as the lower right of the picture. We can see the blue nodes. That's the condition. That's the value, and we can see if then as a leaf node, we can decide is in the red group or in the green group. For the decision tree structure, it has a root node and also has internal node. The internal node is just the decision points to decide if put the left tree or the right tree or until reached leaf node. Leaf node is the final buckets. For the tree algorithm, it's very important to know the splitting criteria. For the tree, we first have a group of data, and then we use some criteria to split into small sets until we reach our final decision tree. So the matrix for the splitting the data side for the criteria is very important. When we split into subsets, the data may also mix, but we will not stop until is 100%. Usually we can accept those some noises. Such a decision tree and can be adapted to more general situation. We use for the two criteria. One is information gain, which use enthalpy. The other way is Gini impurity, and it use Gini index. Now give you a sample like the left picture. We can see those two samples are mixed. We want to use decision tree to draw the boundary. The boundary can be drawn like the right side of picture. We can see it's not the same as our previous boundary. Previous we have some curve boundary or straight line boundary, but for the decision tree boundary is composed with several parts. It's totally different from the previous ones. Using the decision tree has the following benefits. First, decision tree is just like our everyday how to make a decision. We also use the decision tree in our real life. So if we use this algorithm, the final data is easy to interpret. The second benefit is that it's not a Euclidean distance, so there's no use needed to use the feature scaling. For other algorithm like SVM, those methods need to use the feature scaling. The last benefit is it can upgrade to a complex classification methods like random forest or other methods. That's all for today. Thank you very much.